My name is Vic. I am today going to be talking to you about using the Google Docs APIs to store all of your data in the cloud. So if you have any thoughts about the talk, or if you want to get a hold of me after the talk, or any of that, you can get a hold of me on Twitter or Buzz, and there's some popular hashtags down there at the bottom. Actually, a lot of us speakers this year have been creating androids of ourselves. And I think that was a bad idea because I think I've spawned like this like robot army of ginger droids there. So the first one, watch out. OK, so the Google Docs APIs. What we're going to do is start off with a pretty basic statement. After I tell you about my speaker meter. So if you want to give me feedback about the talk or feedback about how I spoke or something like that, just take a picture of this QR code with your device. And then you can submit feedback with speaker meter. So have people been using speaker meter so far? Yes, no? A couple people. It's really, really useful, and I really appreciate your feedback. Sorry, I just see some people taking pictures. OK. So, sorry? It won't scan? All right, just hook up with me afterward. OK, so basic statement. I think that we can all agree that cloud storage is really a revolution in both the abundance and the availability of user data. So nowadays, we have tons and tons and tons of data, and it's really highly available. Like, we can access it in milliseconds. So that's huge, right? If you remember a decade ago, we didn't have so much data, and it wasn't as available. So even 20 years ago, big mainframe systems, and the data wasn't necessarily available. So as developers, our job is really to assist users in some way. But it's really hard to assist users when the information that you need is not readily available via something like an API. So, and additionally, users need access to their data too from more ways, more locations, and more devices. So I mean, you all got tablets. I'm sure you're accessing things like Google Docs right now because that's what this talk is about. And you couldn't do that yesterday or maybe 5 years ago or 10 years ago. So I think what we're coming to is the fact that a cloud storage API has pretty much a strong set of requirements today. And these requirements seem to evolve over time. But sharing is really important. I think we can all agree that sharing data today is as important as it's ever been. You should be able to easily share your thoughts, share your working documents, things like that with other people. And then once you've shared that data, it's really got to be consumable. So data should be consumable in a useful form. Being able to access your data on a disconnected device is nice, but also being able to access it from different types of applications or from a web browser, things like that, in useful forms. And then that leads really into the requirement for web UIs for applications. So web UIs are needed a lot of times if a specific device application isn't working out, or you don't have access to it, or you're on just a generic workstation device, things like that. And then lastly, another advent of the modern age is that we have more computing power than ever. At Google, we have a ton of computing power. And so there are ways that cloud services can be applied to this existing data in ways that individual applications or clients can never achieve. So the Google Documents List API is just one such example. But you might be thinking to yourself that the API only stores documents, and that's actually not true. The name Documents List API is a little bit misleading because the Documents List API actually stores all file types now for all accounts. So today I'm announcing that arbitrary file type uploads are now enabled in the API, and you can now use the API for general purpose cloud storage for all Google users. Whereas previously, this was only enabled for, thank you. Yeah, so a lot of users in the community have been pretty excited about this feature. Previously, if you're unaware, this was only enabled for Google Apps for business customers, but we decided it was time to release it for everybody. So here's just an example of using the API for more than just Docs. So this is a view of Google Docs. And up here, you can see some things like I've got my stocks tracking spreadsheet and my bills tracking spreadsheet. But I've also got things like a local backup tarball. Okay? So for you nerds out there who like .tar.gz, or maybe you're like, well, why didn't you use a bzip file? Well, you can now store all of these things in your Google Docs. And I've got other things up here, like a recorded audio file, a video, which I can play in Google Docs, things like that. And then they're organized in a really intuitive way with collections. So this is different than other storage APIs, and it's different in a lot of ways. Firstly, the storage is per user. And this is a very, very significant distinction. So users control their storage quota. Okay? Whereas with traditional cloud storage, what you're doing is you, as the developer of an application, are renting out space somewhere. Okay? And then you are consuming the user's data and storing it somewhere. With the Google Documents List API, that's different here, where the user is giving you their quota to use. So the actual upfront cost to starting developing with the Google Documents List API or the Google Docs Cloud is actually nothing, right? Because your users already have their storage quota, and you just provide them the application. So very, very easy to get up and running. Data is inherently structured within the UI. So there are built-in collections. There's built-in hierarchies in those collections. We're going to talk about those a little bit more later. And then all entries also have the same metadata. So whereas you, in a traditional cloud storage system, you might have to track all of the metadata yourself. Here, we at Google track a common subset of metadata for each individual item. For instance, every single item has a title. And then lastly, currently documents in the Google Docs list occupy 0 bytes of quota. So this might be something that we change in the future, but it makes it really, really easy for you to create a lot of documents and use up 0 bytes of the user's quota. So you get a lot for free with very little overhead using the Documents List API. So all of those things are nice, but the real meat of this talk is in developing a real working application. So this talk is going to be pretty technical. We're going to go through building something similar to one of these other existing real applications. So we have spanning backup for Google Apps. They build a backup utility that backs up your Docs, Contacts, and Calendar to the cloud. Syncplicity builds a PC, Mac, and file server syncing system to sync files for your enterprise. Memeo builds Memeo Connect. And Memeo Connect pretty much allows you to sync your PC, iPhone, or iPad with Google Docs. And then lastly, we just launched the Google Docs app for Android. And the Google Docs app for Android allows you, obviously, to access all of your documents and files from your Android device. So all of these are really strong, well-implemented solutions that have many, many users. And they're already implemented today using the Google Documents List API. So this is a tried and true API. And we have people developing on it actively. Actually, I think both Spanning Backup and Syncplicity are here today. So if you'd like to talk to them, feel free to find them. So before we go into the deep technical parts of the talk in developing a real working application, we need to take some basic information about the APIs. And that basic information really comes down to terminology. So when you're working with a Documents List API, actually, who here has worked with a Documents List API before? Could you just raise your hand? OK, so maybe a third of the room. If you haven't yet worked with a Documents List API, you need to know that a document means anything that you can edit in Google Docs. Okay? So an example is a spreadsheet. If you create a spreadsheet, you can then edit that in Google Docs. Whereas a file is considered anything that you cannot currently edit in Google Docs. So if you, for instance, upload a video, you currently cannot edit that in Google Docs. It doesn't mean that we won't implement that in the future. But right now, it's just some arbitrary file that you upload to the cloud, and you don't intend for a user to edit from the Google Docs interface. And then there's a collection. So collections need a little bit of an explanation. So collections are like two things. They're like a folder, and they're like a label. They're like a folder in the sense that collections have a hierarchy, right? So folders on a hard drive, whatever, have a hierarchy. So in the root folder, you might have my documents and then my photos, things like that. Whereas a label can be applied to multiple things at the same time. So you can apply multiple labels to the same object. So a collection is like a label with a hierarchy. You can put a hierarchy within these labels, but also a document or a file can belong to multiple collections at the same time. So we actually have been doing this for quite some time, and we realized that folder wasn't really the right term, so we started calling them collections because they're very much more powerful than a folder. And then lastly, a resource is a document, file, or collection. So if you hear me say the word resource today, I'm just referring to one of those three things, because in the API, we actually abstract out the way you work with these things, so that if you wanted to, for instance, change the title of a collection, it's the same as changing the title of a document, so that you have to implement less code. So in building our example real application, what technologies should we use? Well, there's quite a few. The first thing we're going to do is use OAuth, which is open authorization, to get a user's permission to access their documents list. So really quick, I just wanted to discuss the difference between authentication and authorization. Authentication is the mechanism of identifying a user, whereas authorization is the mechanism of getting that user's permission to do something. Okay? So authentication happens when you browse to gmail.com and have to enter your username and password. Authorization happens when Google asks you, would you like to allow this application to access your Google Docs? Okay? So those are two very distinct terms, and people sometimes mix them up. Here we're talking about authorization only. We're not going to worry about any usernames or passwords. So when we implement OAuth, this is essentially a mechanism for us to get a user's permission to access their docs and then do so with a token. We're going to use App Engine to host the application. You could obviously host the application on any provider you'd like, including your own servers. But it's really easy to get an application up and running in a short amount of time on App Engine. So I'm going to, just by chance, use App Engine today. We're also going to use JavaScript and HTML5 to give a usable interface. Like I said, this is a real application. So we're going to implement the full thing, from the App Engine app to OAuth to all the way up to the user interface. So there's a whole bunch of other talks on JavaScript and HTML5. The things that I'm going to do are not nearly as advanced as some of the things in the other talks, and I recommend you attend those if you're more interested in these topics. And then, of course, we're going to use the Documents List API to manage most of the data. If your data has a custom schema, I highly recommend you use the Spreadsheets API. So the way this would work is if you needed custom fields, you would use the Documents List API to create a hidden spreadsheet in the user's account. And then you would use the Spreadsheets API to manipulate the data in that spreadsheet and store arbitrary data for your application, all within the user's control. So what does the application do? Let's take a quick look. So I've got this application running on localhost :8080. And it's just because I have the local App Engine instance running. So if I browse here, I'm immediately taken to the Google Accounts page, asking me to grant access to this application for my Google Docs. So the application is immediately sending me here just to click grant access, essentially saying, yes, allow this application access. And when I click grant access, I'm taken to the application. So let me go to full screen here. So here's the application. It's called Categorically. I'm sorry, I couldn't think of a better Web 2.0 bad name. So the purpose of the application is to allow us to easily update our Google Documents list with files from our desktop. So here I have a folder with some stuff in it. Here's an image I took at Half Moon Bay, which is here in California. Here's another image of some berries on a tree, I think. And then I have a zip file of both of these images. So my goal here really is to easily get these into Google Docs from our sample application. So the whole purpose of this is to be able to drag one file from our from our binder and into a collection here in our Google Docs. So let's see, I'll drag this to my book. I'm not really writing a book, I just created that folder. And so that's it. The application refreshes, we're done. So where did the file go? Well, if I pull up Google Docs, and I think I called it archive.zip, if I search for this, here it is, and it's in the correct collection. So let me zoom in here so you can see this. So I actually uploaded it to the My Book collection, and here it is on top. I've actually uploaded this file before to test, so that's why it exists twice. But My Book, and then if I click on this, you'll notice that this is an example of a file, and I cannot currently edit zip files in Google Docs. So here I'm taken to a more generic page that describes some information about this file. For instance, like which collections it's in, or what size it is. It allows me to download it from the web UI, things like that. So everybody understands the general purpose of this application is just to make it really easy to drag and drop files from the desktop to here. So how did we implement this? This seems like a really simple application, and there are a lot of parts, but I'm going to go through today and show you just exactly how all of this works together. So when we walk through the source code today, we're going to walk through it in a couple of steps. First, I'm going to go through how to create an App Engine app, specifically a Python App Engine app, but you can do all of this in Java. Then I'm going to implement three-legged OAuth. And when I implement three-legged OAuth, that's going to take a little bit of explaining because we have to do this thing called the OAuth dance. We're going to implement a JavaScript and HTML5 user interface. And then lastly, we're going to use the Documents List API to manage everything. So this is this whole application comes out to be about 375 lines of actual code. So if you'd like to follow along from your laptop or at home, you can just follow this Google link to the source code for this entire application, which is all open source. So that's just NAKZM. So let's take a look at the source code. Here first, I have this App Engine app set up so that I have a README file, and I have an app.yaml file, things like that. These are basic App Engine appliances, and I'm not going to go through those specifically today because there are separate talks about App Engine. What I am going to go through, though, is the app called gcategorically. And so here's all of the source code for gcategorically. So you can, if you're familiar with Python, here we have an init.py, which is pretty basic for declaring a Python module. And then the handlers are the important bits of information here. So you can see we have an OAuth handler to handle the OAuth portion of the application, a collection handler to handle manipulating collections, pulling down the list of collections, things like that. And then we have a default handler, and all this really does is render the main page. It's a little bit difficult to see on the screen here, but there's a directory over here called static and a directory over here called templates. So static just includes all of our JavaScript and CSS files. And then templates just includes an index.html file, which we use to render the main page. So let's start by taking a look at default handler. And anyway, so here, pretty basic stuff. This is just a license declaration, author. None of that's really important. Down here is where we actually get to the meat of the code. So since this is an App Engine application, the way uploading files works is with a blob store handler. So you can think of a blob as just some arbitrary blob of bytes. And a blob store upload handler just handles uploads of these bytes, stores them somewhere temporarily, waits for the application to use them in some way, and then you can just delete the temporary file. So again, with App Engine, we create a handler, and then we define methods based on the HTTP request method we're using. So there are a number of different HTTP request types. We have like get, put, post, and delete. Those are the main ones for a RESTful API. And here, it's just really easy to implement get and post. So when we run a get request to the default handler, we're going to do a couple of things. Our goal is to generally render the main page, but we have a couple of sub-goals in here. We're going to create an OAuth token handler, and then get an authorized client. All this really allows us to do is say, give me some abstract object that is authorized to work with the Google Documents List API. Okay, so it's just those two lines of code. If client comes back as none, then we need to authorize. Okay, so just redirect the user to the authorization page. But if it doesn't come back as none, continue. Give the template index.html an upload URL where the user can upload their files, and then render that template to the screen, essentially. Post has a different goal. Its goal is to receive a file from the user and then send it away to Google Docs in the appropriate collection. Okay? So again, when they come in, OAuth token handler, get authorized client. So these two things are just, again, doing the authorization steps. We're getting the parent, which is a parameter being passed in from the client. This is just telling us where the user wants the file to go. Okay, so the parent is just going to be the resource identifier of a collection. Then the URI we want to post to is documented in the Google Documents List API documentation. Essentially here, this is some predefined URL with which we can upload documents and files to a particular collection. And you can see here, I do string substitution to replace the parent that they gave us into the URL. And you can see up here, this is secure because I do a regex replace for malicious characters. So down here, I'm going to get the files uploaded from the user. And for each file, if the client is none, then we need to authorize. Okay? So back up here, if we got no client that was authorized, then we need to send the user to the authorization page. Does that make sense? So then we're going to use this utility class called resumable uploader. And this allows us to do a lot of things. In bandwidth-constrained environments, you usually want to use a resumable uploader, because what that allows you to do is send a file off in chunks, and that's very important. So if you're working, for instance, on a phone, and you have a very limited connection or limited bandwidth, I highly recommend you use resumable uploader, because now you can split your, for instance, 10 megabyte file into chunks of 256K and send those chunks individually. If an individual chunk fails, you can resume from that point. So very, very useful to use the resumable uploader. It's also required to upload files in the Documents List API, but you may as well just use it for everything because we have future plans to just make it the default. Here we're creating a Documents List entry. This is just a wrapper class that has some basic things like a title in it. So here you can actually see me set the title to the file name of the file being uploaded. So in the demonstration before, you saw me upload archives.zip, and the title of the file was actually made to be archives.zip. Lastly, I'm saying to the helper class to upload the actual file to the Google Documents List API. Down here, this blobinfo.delete, that just deletes the temporary file, because when you upload a file from the client side to a web server, it has to store it somewhere. So we're just deleting the temporary file and doing good housekeeping. After that, we're redirecting to the main page. So after they drop the file, we're just redirecting to the main page, showing them the user interface again, and they can upload more files if they wish. So that's pretty much it. The rest of this file is just going to create a WSGI application. If you're not familiar with this, just read the App Engine Python documentation. Setting this up is part of the Hello World project. This is just a basic way to interface that handler that we just wrote with App Engine's interpreters. So that's pretty much it for the default handler. And that handles displaying the main page and receiving files. But we kind of skipped over a lot of stuff. One major thing that we skipped over was all of that OAuth logic. So the way OAuth works, essentially, is you have to, when a user comes to you unauthorized, you have to generate a request token and then send that user off to Google, or off to the OAuth service provider, identity provider, excuse me. So the OAuth identity provider is the person, or the entity who's going to say, yes, this user is legitimate, and yes, this user gives your application permission to do something. So in this particular case, the identity provider is Google. So what we want to do is redirect the user to Google with a request token. Google will allow the user to click allow access. And then the application will redirect the user back to our application with a special parameter in the URL. Okay? That special parameter is an authorized request token. And then our application is going to take that authorized request token and turn it into an access token. All of this is, I agree with you, a little bit complicated. That's why we write sample applications, and you copy and paste. So what we're doing here is we're creating a new OAuth token handler. We're creating a new client. Here, remember, I used the term request token. So we're just getting a request token. And then we're generating a callback URL. This just says, hey, Google, after you're done authorizing the user, send them back to this spot. So that allows the user to be bounced around in their browser pretty seamlessly. So here, we're getting a request token, and we're storing it temporarily while we send the user off to Google. Because when they come back, they're going to have an authorized request token, and we need to be able to look them up somehow. After we store it temporarily, here's the redirect request and the authorization URL. And then once they come back, there's an authorized request token, and we're going to upgrade that to an access token. So this access token is what allows us to make requests via the API. So your application will store this access token for an indefinite period of time, and then use it to make requests that, to perform your application's basic functions. What's important about this is that a user can revoke this token, and what that means is they can pretty much stop allowing your application to access their data for a number of reasons. And if they revoke this token, the access token will no longer work with the API. You'll get a 401 unauthorized error when this returns. So that's actually handled in some other logic in this file, but that's not really relevant. This is just handling the OAuth dance, and that's the important part. And this stuff up here is just used for basic key management. It's important to note that here I'm using the documents list API scope. So the token I get back is scoped for the scopes that you request. So here I'm requesting docs.google.com/feeds. That's the base URL of the Google Documents List API. And when this scope comes into the authorization logic on Google's end, what we do is look at these scopes and then determine what we have to ask the user permission for. So in this particular case, it's Google Docs. If this said something like contacts in the URL, then the user would see, this application wants to access your contacts. So that's pretty much it for the OAuth logic. I highly recommend you just come in here and copy exactly what I did and not try to implement this yourself, because this is kind of a pain to get working. So that's the OAuth handler. And then the last part starts to work with the Documents List API. So working with the Documents List API, there are a number of best practices. And a lot of those are exposed here in the collection handler. So you'll remember, we have two general goals. The first is to show the user a page in which all of their collections are available in a tree form. And the second goal is to be able to upload a file to one of those collections. So the first thing we're going to do is look at this tree generation. So what we can do with the collection handler is look at something like the generate collections tree method. So what this does is it turns a flat representation of a tree into a hierarchical representation of a tree. So the Documents List API, when you make a request, sends back collections in a flat list. So the root collection may be at the same place in the list as the My Book collection or the Photos collection, something like that. So you just get this flat list. Everything's at the same level. Here we use a recursive traversal to turn this into a tree that we can later walk to show something on the screen. So for instance, when we show this to the screen, we need to be able to recursively generate this, right? Because, for instance, here, protagonists is a sub-collection of My Book. It's a sub-collection of Home. So when we walk through this, we're actually creating a new element for each individual child, and then we're creating an element for the parent, and so on, walking back up the tree. So let me go back. So this is just a recursive call to do this. You can see here parent.subcollections.append, and then I actually call this same method name again to generate the subtree of those collections. There are some other helper methods in here, but they're not really that important. If you read through them, they're obvious in function. So before I call the method to generate the tree, what I'm going to do is say collections equals, remember our authorized client is here, .get doc list. So this is just a helper method to make some HTTP requests and pull down a list of resources from the API. So here, feeds default private full. You can ignore all of that. Hyphen folder. This says, give me all of the folders or all of the collections from the documents list API so that I can do something with them. There's an important parameter here called show root equals true. So by default, collections in Google Docs exist with no understanding of a root collection. Okay? So there's not like a root collection that a user can go delete, right? Because if they deleted the root collection, that would be awkward, right? So we don't expose that in the API. We don't say, here's a root collection that you can manipulate just like other collections. You can't delete this, so we don't even show it. It's just assumed to exist. So here, when we say show root equals true, what we're actually doing is saying, for all of the other collections, give them a special label if they are in root. Okay? So we still don't give you back a root collection, but we say for all of the other ones, if they happen to be at the top level, say so. Okay? And then here, for I in range collections, we're just iterating through the number of, or through each collection. We're generating the collections tree and turning that into a JSON form. So this GET request is actually going to be used via AJAX, and we're going to say, to JavaScript, here's a JSON tree representation of all of the collections in this user's documents list. Now it's up to you, JavaScript, to turn that into a user interface. Okay? So this is server-side logic. We're doing the tree generation server-side, and then the client is receiving that and turning that into a UI representation. And then here, you can just see that we set the content type of the response to text/JSON, and we write out the tree. So that was collection handler. Let's go back to the UI and review everything that's happening. Default handler is generating this page. By default, though, if I refresh, for instance, whoops. Sorry, I killed my App Engine app. Oops. So let me just start this back up. Here. Yeah. See, App Engine is as simple as that. Here, you can see the title loads first. Why does that happen? There's a slight delay. Let's look again. Title loads first, then the rest. It's because the title loads first as part of the base template, and then an AJAX request is being made to collections.json, that method that we just looked at, to fetch this and then generate it in the UI. Okay? So why do we do it this way? There are a couple of good reasons. Firstly, in general, for large numbers of objects, you don't want to do tree generation client side. Okay? You don't want to iterate a very, very large number of objects or do some recursive generation in the browser. You would much rather do that server side, cache it, and then send it to the browser, right? Because our thousands of servers are frankly faster than your MacBook Air. So let us do the tree generation, and then we'll just send it off to the client already generated, and then it just creates a much faster experience for the user. It also allows us to do things like caching server side, so we can just spit out the response without even bothering to go refetch the whole collections list. And then we can do things like cache expiration detection, where we just pull the documents list and look for a change. And if there's a change, we'll expire the cache and then refetch. So all of that should be transparent to the user. So again, that's why you get this delay here between the title and this. And then what we could do is, for instance, cache this browser side with local storage in HTML5. So what else is going on here? When we drop a file on, something has to happen, right? There must be code in the world that handles this file drop action. And we haven't looked at it yet, so let's take a look at it now. Firstly, in Chrome, if you go to inspect element on anything, you'll see a whole bunch of stuff that we don't really care about. And then you'll see this input type equals file. Let me see if I can zoom in here. Whoop. So input type equals file, name equals files, multiple, class equals file. OK, so the word file is probably used too many times there. But essentially, its type is file. So an input type of file means you can browse for a file, select it, and then click upload later on. And then its name is files. So here we're just saying we're going to accept multiple files to be dropped at once. So I could grab all of my photos, drop them on a collection, and then just boom, they all get uploaded. And then class equals file. This is important for a different reason. So you don't see an upload button here at all, right? So what we're doing is something very, very sneaky. We are, on this file object, setting its opacity to 0, and its position to absolute, and then making 100% width and height. So what we're actually doing is hiding the button, and then we're expanding the whole thing to fill this entire cell, so that if you drop anywhere on this, we'll receive a drop action on this file input. Once we receive the drop action in JavaScript, we can work with it. So let's take a look at the actual JavaScript that does this. Let me go to G categorically again, and static.js, base.js. OK, so more code. A whole bunch of stuff is going on here. Most of it is irrelevant. Refresh collections. All this really does is generate actually, it takes a collection tree that was generated server-side, and it renders it to the screen. So here, you can see render collection tree. So let's find render collection tree. So here's the method. So you can see a whole lot of stuff is going on. All this really does is generate some HTML elements and then put them into the DOM. Okay? So we're creating a new cell, a cell being the thing that contains the collection, like my book. And then this is a div element, so basic HTML here. And we're giving it a special CSS class. Okay? And then we're appending a form. And we're giving the form some parameters. Then we're appending a label and a couple of input fields. So all of these are important. The input field here is called parent. Remember, we have to say where this file should go when you drop it. So parent here is the resource identifier of this individual collection, which is some arbitrary string of characters just to identify this particular collection. Here we have a submit button. We're going to hide this in the UI because the user should never have to click submit. This is like the Web 2.0 era. So submit buttons are so obsolete. And then we have the file input that we just took a look at. And here we're setting those attributes that we just saw. So let me go back to the browser. Remember these attributes. So we have input type equals submit, input type equals file. Those are actually generated right here. So input type equals submit, input type equals file. So in JavaScript, we're just dynamically generating these elements, and then we are appending them to the DOM. And then lastly, on this form input, we are, sorry, I misspoke. On this file input, this one, what we are doing is binding it to a change event. So the change event means like somebody dropped a file on here, and then we're calling the click method on the submit button. So Web 2.0 era, we can click buttons for users. So here we're just calling click on the submit button that we created right here as soon as somebody drops one or more files onto the input. And then that's it. So that's how we're handling the drop event. So again, if I come back here, essentially the use case is I take a file, I drop it on a collection, so my books. And then the upload happens. So when that happened, we're just submitting the form, the hidden form. The hidden form is submitting off to the URL that we provided earlier. And then we automatically get rerouted back to the main page after the file has been uploaded. And then the file shows up, something like this. So that's a pretty basic introduction to what this code does. But again, if you walk through it, we just have a couple of different things to manage. And most of the code is marshaling data between two handlers. It's a lot of helper methods. The meat of the application is actually only a couple of lines of important things. So let's go back to the presentation, if I can find that. And let me go to full screen. Oops. OK. So let's go through some best practices, because you're all here to learn deep details on how to use the API best. Firstly, use resumable upload for everything. It's only a good thing, and it's very easy to use. There's no barrier to entry. And it allows you to use the application in more environments on more devices. You should fetch as many resources as possible in a single request. Why is this good? Well, firstly, there's a round trip time for any HTTP request. I mean, we're Google. We serve things really, really quickly. But there are networks in between that don't go so fast. And so you want to reduce the number of requests you make as much as possible. So for instance, I want to pull all of the collections in a single request and then manipulate them. Okay? I don't want to pull them in multiple requests and have to just load up my list and then manipulate them. That's a longer process. You should cache each resource individually. So with the Documents List API, you get a list of resources back. Each one should be cached individually so that you can expire caches on an individual resource basis. Okay? So if one resource changes, why would you refetch all of the other resources? That doesn't make any sense. So cache each resource individually, and you will drastically improve the performance of your application. I've already said, perform collection tree generation server-side, and then cache the collection trees and their contents server-side as well, so that you're just sending down to the client the processed data, so the client doesn't have to do anything on their end, especially if they have a device with not a lot of power. If you're implementing something like a synchronization client, each resource has this field called app edited. And what that means is when that date changes, it implies that the user has made some change to the resource. So for instance, if we take the example of a text document, if the app edited date changes and your application notices, that would indicate that the user has logged into the Google Docs user interface and changed something in the document. So that something could be, they bolded this word or they inserted this image, anything. Some more best practices. When sharing resources with the Documents List API, you can share with a key, and this is like a top secret password that gets appended to a URL, and then everybody you give that URL to can now access the document. So it's not really that top secret because people can just share the link, but it essentially restricts access based on having a link. So one question that I get a lot is how do you set the initial key for this URL? And the answer is you can't set the key. We just generate one for you. So when you set the initial key, it's going to automatically be overridden. So you can put like my super secret password in there, and we're just going to throw that out and use something a little bit more secure than my secret password, right? Also, access control list requests, so essentially sharing requests, should be batched together as much as possible. If you have an enterprise domain and you're trying to share something with 1,000 out of 8,000 of your employees, you should batch those requests, those individual share requests, into single requests, into a single request to the Documents List API, right? So why send 8,000 requests to the API when you could send one, right? Remember, a smaller number of requests is better. Also, to share a large number of items at once like that, it's actually best to put them all in a collection and then just share the collection. And if you share a collection, that will give view access to everything in the collection by default for every user that you share it with. We've also added some features recently that allow you to easily back up an employee's documents list. using admin access on your Google Apps for business domain. Okay, so I'm not sure how many people here work in an enterprise setting. So you develop apps for your company. This is actually important for you. If you have a company, or I misspoke, if you have an employee, for instance, leave the company and you need to do some sort of discovery on all of their docs or something like that, a Google Apps administrator only can access this and impersonate that user just to do a backup. Okay, so that just eases a lot of hassles with Google Apps domains. My final best practice is to use OAuth whenever possible, without exception. So if you have a choice between using OAuth, auth sub, client login, definitely use OAuth. Even if you're writing an application that is installed on a server, okay? So for an application that's installed on a server, where you can't, for instance, show a browser and then authorize, this token, what you should do is, if you don't have a Google Apps for Business domain in which you can use two-legged OAuth, that means you have to use three-legged OAuth. And these terms, again, are discussed in other talks here. But three-legged OAuth can be done using a stored token. So what you would do is, in a web browser, run through once and authorize a single token. And then you would essentially paste that token into your script or into your program that's going to run on the server. And now that program can make authorized requests indefinitely. Okay? So no web browser involved. That's kind of a way to circumvent the need for two-legged OAuth, which skips the browser. Okay. So, in closing, you should definitely be considering the Documents List API for any of your cloud storage, especially because it's free to use, and your users are going to pay for the quota. Okay? Well, actually, not even pay. We're just going to give it to them. So this is a much better solution than some other options. And additionally, you get things like a built-in web interface for all of these items, built-in sharing, and built-in resource management from the user's end. So just for some more resources, you can take a look at the documentation, which has a Google link there, and also the forum. So if you have a question and you, for some reason, cannot find me on the internet, you can post in the forum, and myself or one of our very small team will respond to you. I was responding to posts on the forum at like 4 a.m. this morning, okay? And we're dedicated, right? So then also the code for the sample application is right there. And I just wanted to give a quick thanks to a couple members of the team. That would be Rob, Russ, Ivan, and the rest of the Google Docs team. So I feel pretty passionate about this product, and you should too, because a whole lot of good work goes into this product. When I look at where we were, for instance, 4 years ago versus today, it's just night and day different. And now we're providing a really stable, sustainable API for your consumption. So a great thanks goes out to those guys who do a lot of great work. Lastly, if you wanted to tweet or buzz about this talk, you can use these hashtags down here. And if you want to give me feedback again, please use SpeakerMeter. The QR code is here. So that's it. Thank you very much for your time. I appreciate it. So I just wanted to take questions at the microphones, please. Oh, yeah. Let me go back to the previous. Did you have a question?
Yeah, that'd be great. Hey, how's it going? Thanks, great talk. I've been using Google Docs for a couple years,
Okay.
the API. I guess I've implemented something using Google Docs in the cloud, and it's great. And I think there's other opportunities to maybe do, there'd be opportunities for me to port the solution I did in the cloud to a closed enterprise environment if a Google Docs appliance was something that existed. And I guess I was wondering if that's ever been on a roadmap.
At this time, I'm unaware of a Google Docs appliance, unfortunately. However, in an enterprise setting, you can actually do a lot of things to restrict access to Google Docs. For instance, you could implement SAML single sign-on and then put the single sign-on page behind a firewall in your organization. And that would actually restrict a lot of access to things like Google Docs, because now, as the single sign-on provider, you're telling us who is authenticated, and because of that reason, if the user cannot access the authentication page where they enter their username and password, they can't log in. So if you'd like to talk to me afterwards, I can tell you how to implement that.
Cool,
Yeah.
thanks.
Yeah. Hello.
Hi, thanks for the talk. I was wondering if there's, as a Google Docs API question in general, when requesting a resource or entities from a specific collection, is there a way to only ask for items within that collection that have, only those items in the collection that have changed? So I request,
Yes.
you know, from a specific folder, and it gives me everything in that folder. But I mean, I only want the things in that folder that have changed.
It's funny you would ask that question to me, because my answer to you is that not yet.
Okay.
Yeah.
That would be nice.
That's something we're definitely considering, though.
Okay, thank you.
Hello.
Hi. My question is, you said if you wanted to store like your own document types in there, like use the spreadsheet API or anything like that, is there any way that there will ever be a way to where you register your own file types through the Google Docs interface, it would launch out to your app? Or do you really have to do like you did and put your own face on top of it and really just use Docs for storage?
Also a very interesting question. That is something we are considering.
Okay.
Yeah.
Hi. So you mentioned that administrators can impersonate an employee, which is something that our company, as a Google Docs user, is very interested in. Employees who leave, we want to make sure we can get access to their documents. Can we only back up a list of their documents, or can we actually back up the contents of each document?
Actually, you can fully impersonate the user. So anything else you could do in the API, you could do while impersonating them using a Google Apps admin account.
Okay.
Yeah.
Great.
Yep. Hi.
Hi. Is there like a high-level GDocs API in the Android? I'm building an Android mobile phone app that I want to upload a file in the Android application into the user's GDocs, like
user's
Gmail account. Is there
Gmail
kind of
account.
like a high level? Or?
So can you describe your ideal outcome? Would it be an email in their inbox with the file?
No, we would like to just have like a button and then an API that we would take our file and then just, it ends up in the GDocs.
Oh, the Google Documents list. This API can do that for you, even from an Android device. So the API itself at its core is an HTTP RESTful API. So you send off essentially web requests to do stuff. However, we implement a Java client library, a Python client library, a .NET client library, and a PHP client library. And the Java client library is ideal for your use case because you would take the Java client, drop it into an Android app, and then you could just, you'd probably register an intent or something to, just send the file off to Google Docs. But yeah, totally possible. In fact, I mean, we did it with the Google Docs app for Android.
Sure. Okay, thank you.
Yeah, pleasure. Hello.
Hi. Is there any way to...
I'm sorry, I can't hear you. Can you come closer?
Hi, can you hear me now? Hello? Can you hear me now?
Yes.
Okay, sorry. I was wondering, is there a way to implement version history when uploading files?
Yes, we have full revision history support. You can create, retrieve, update, and delete revisions with the API today. If you're interested in seeing how to do that, just let me know.
Okay.
But you can do arbitrary file revisioning of anything that you upload.
Okay.
You can also consume revisions from documents. So for instance, in a text document, as you're typing away, if there's like a conflict or something and you need to fork a new revision, you can access those in the API today.
Okay, thank you.
Sure. Hi.
Hi there, and I'm sorry if this question was answered. I missed the first half of your talk. What's the supportability SLA, backwards compatibility API story for this stuff?
I'm sorry, I still can't hear you. Can you come closer to the mic?
Sure, yeah, I guess
Thanks.
the microphone's, it's very loud right here. So the question was, what is the supportability SLA, backwards compatibility, deprecation, et cetera, story for these APIs? we've done an integration with our application with Google Docs, and we've had great trouble with APIs changing unexpectedly over time. Now, a lot of this work was done 18 months to 2 years ago, so maybe things have stabilized, but I know we were trying to get some information from Google about just backwards compatibility and deprecation changes. Can we rely on the API for a period of time? Do we need to be, is there a blog? Is there an RSS feed we should monitor?
There is a blog. It's called the Google Apps Developer blog. That will tell you essentially all changes that happen with the API. There's also an RSS feed in the documentation called the release notes, and that tells you any changes that we make. I also wanted to point out that sometimes my purpose in life is to make sure that things don't change so that you don't have to re-implement your application. And I mean, really, sometimes I think I take it too far. So we try really, really, really hard not to change something, but there are particular circumstances in which we cannot avoid breaking backwards compatibility that we feel for our users' benefit we must implement. And those are really the only occasions in which we will break backwards compatibility. That said, our out-of-labs APIs have a 3-year deprecation policy in which if we are going to break backwards compatibility for a non-important reason, we have to give you 3 years notice, okay?
And are these APIs in the labs, or are they out of labs?
So the documents list API is actually in both. Version 2 is out of labs, stable for 3 years. And version 3, we are actively developing it. We're adding features left and right. And because of that, we haven't brought it out of labs yet.
Great.
Yeah.
Thank you.
Yeah, pleasure.
Hi.
Hello.
Using Java API, can we create labels?
I'm sorry, delete?
Using Java API, can
Yes.
we create labels, folders?
Can it integrate with folders? The Java API?
Yeah.
Yes. The Java client library implements every function of the API. So you would essentially call, my client.get doc list, just like I showed on screen. Actually, the method I think is called the same exact thing in Java, but I showed a Python sample. So, yeah. There's a Java developers guide you should definitely check out.
Thank you.
Yeah. Hello.
Is there a way to get the last modification date for the access security settings on a document?
For the access time?
Yeah, so if a user's been added, to tell if the ACL is changed.
Yeah. So talk to me afterward. It's a little bit complicated to implement, but I'm happy to help you do it.
Cool.
Hello.
Hi. We use the doc list feed to integrate with Google Docs and synchronize files with devices.
Yep.
So you are able to edit those files from the cloud or from the device. It works really nice. Okay, so the API works very well. But the problem is that we would like to know if a document of the user had changed without having to pull the Google Docs system every time to know if there is something new.
Yeah.
So is there a way to know that the file has been changed?
Yes.
That there is a new file?
Yes. I think I mentioned this in best practices. The app edited date, the last point here. This is provided for each resource given by the API.
Yep.
So what you would do is cache this date locally on your server or in your application, along with the resource identifier. And if you noticed that this date changed, you would know that the file changed.
Yeah, but we have to pull the servers to know that.
So
if there is a way to be notified when something changed.
Yeah, I'm with you. So this goes back to a previous question in which I said that is definitely something we are considering, but I have no other information at this time.
Okay.
Yeah. Sorry.
Thank you very much.
Yeah. Any other questions? OK, thank you very much.